Okay, this is, I'm going to be talking about a project we did for the Commonwealth Department of the Environment, which was a commitment under the National Waste Policy, which was to look strategically at hazardous waste infrastructure and the demand for it. It was undertaken by a consortium, Blue Environment, together with Randell Environmental Consulting and Ascend Waste and Environment, which is Jeff Latimer and Paul Randell, and myself. 3 parts to this project then. 20-year projections of hazardous waste arisings and fate. Arisings, well, I'll get to that word in a bit, and fates. Estimate current capacity and its distribution and combine these roles to look at current capacities and needs. Now, this is obviously a top-down process, and on top-down sort of things, you get some good things and you get some things that are not so good. We'll talk about those. It was a large project. It's also unfinished, which is a bit unfortunate. We were scheduled to have, I could show you final results here, but the project's taken longer. In particular, the Commonwealth employed peer reviewers, and that took a bit of time. Anyway, I'll scan it and I'll cover the interesting bits. So, what is hazardous waste? Well, for us, it was materials that are subject to higher levels of jurisdictional regulation, which the jurisdictions tend to call trackable, listed, prescribed, controlled or regulated waste, depending on which state or territory you're in. We also chucked in a few other materials that are not so controlled. New persistent organic pollutants declared under the Stockholm Convention. And this is one of the key things of this, which drove the Commonwealth wanted to go ahead with this project. The Stockholm Convention has declared a new batch of chemicals as persistent organic pollutants, but Australia has not yet signed off on those, so they're not yet hazardous waste as far as we're concerned. And also, we haven't decided what is the concentration threshold which will define which one of those wastes is. And there's flexibility for Australia to pick its own. So that means there's a bit of sort of wiggle room there, but there certainly is a potentially serious issue which hasn't been considered from the point of view of, well, how would we deal with it? And indeed, where is this stuff? Another one is contaminated biosolids. Now, we have made up that word, contaminated biosolids, and the reason is, and hopefully there's nobody here for the water industry. The water industry hasn't quite got, I think, understood the implications of the Commonwealth really trying to push, well, is it contaminated or not? Which ones are contaminated and which ones are not? What's the circumstances? What's the threshold? Now, the water industry is a big beast of its own, on its own, and biosolids don't tend to be counted very much in with solid waste as a solid waste issue. And so it hasn't fallen quite under the systems. But certainly there are biosolids which have levels, thresholds of heavy metals and various other things, including some of these new persistent organic pollutants, which could, if they were anything but biosolids, they would certainly be hazardous waste. Where they are, when they are, and all the rest of it, we really haven't quite got a hand on it. And we had to, in the end, invent this term. So we are trying to push from, in a sense, from the solid waste perspective into this liquid waste or the sewage waste problem to try and resolve, or to trying to get to grips, to start thinking about those things on the same framework we think about all other types of waste. A third one is lithium-ion batteries. Now, they are also not declared as a hazardous waste, and in fact, there's not many of them, but there are projected to be. If the economics turns out as is anticipated, there is expected to be lots of them in the market, and they have a bad habit of sometimes bursting into flames. So do we want them to burst into flames in landfills or MRFs or where the hell is certainly an issue which is not really on the horizon. Now, it was one of the very interesting things about this project is wading into these particular wastes of which there really isn't very good systems at present. Now, one of the key things of doing a top-down type analysis like this is the categories. How do we analyse them? So we analyse based on the NEPM 15 classification. NEPM is the National Environment Protection Measure I can't even remember the full name, but it controls the transport of so-called hazardous waste between one jurisdiction and another. It declares the categories and how they need to be reported, and most of the jurisdictions are shifting their categorisations or setting up their categorisations to match the NEPM framework. Now, the NEPM framework has 75 categories, and the states and territories have clubbed those down to 15, that was the starting point for us. Plus, we broke out some others which were particularly interesting. Here is our hazardous waste groups here. So all these ones that we say A, B, C, they are part of the so-called NEPM 15, and then we broke out some other ones as well: mercury, lead, non-toxic salts. We broke out from their D category to look at them specifically. You can see the list there. Some of them quite familiar. Tyres are declared as a hazardous waste. You see at the end there, and you can see we chucked on lithium-ion batteries at the end there, and you can see the new persistent organic pollutants, PFOS, but the big list of letters there at the top of the column on the right-hand side. PFOS, POP BDEs, HBCD, HCB. HCB is the stuff that's in Orica's stockpile in Sydney that they've been scratching their heads over for 15 years or so now. Okay, so we're looking at those types of wastes. The projection method, which was the first part, we're looking at how much of these materials are likely to arise in the future. I'll just mention this word arise. The issue is that the primary data source is tracking systems, and tracking systems track transport of waste. Now, it's possible that waste might be picked up from a factory, taken to a treatment facility, or even taken to somewhere and then taken to somewhere else. When it is, it's tracked twice. So it's in our database twice. So it's not really waste generation, which should count it only once. It's arisings. We're using the term because we've got potentially multiple counts in there. So our projections method was to look for pre-existing projections. We considered historical data, including these arisings, industry sources, the fates of these materials, as much as we could find out about them, likely futures of the industry sources. We thought about projected population and economic growth. We talked to industry and we talked to governments, and we looked at current stockpiles and what might happen to them, a surprisingly significant issue. We have some big stockpile issues in this suites of waste that we looked at there. Now, yeah, I'm probably a better analyst than I am a salesman, so I'm going to focus on some of the weaknesses of this thing, which a salesman wouldn't. But there are significant uncertainties in doing something like this. There's uncertainties in the data. There's certainly uncertainties in what is the future of particular industries and all those methods we put down there. And there's difficulties ascribing categories of waste to particular types of infrastructure. All those things weaken the findings in some way. And so one of the ways in terms of the projections that we looked at is to account for that by having best, high and low estimates. So we'll get to those. This is the jurisdictional data set we got from the different states and territories. Now, most jurisdictions have got tracking systems. New South Wales, Queensland, South Australia, Victoria and WA have this tracking systems in operation, so that if you produce these types of waste, you have to get a licensed operator. You both fill out a form, or you do it online, saying, yep, this much, this type, this fate, this source, it's tracked, and then it goes to the other one, and everyone signs off on it, and the EPA gets a copy. A massive supply of data, and also an unanalyzed source of data. I don't think anybody has ever collected this in and looked at it collectively before, even the jurisdictions themselves. They don't tend to look at it because it's really there just as a backup in case they have an illegal event occurring and they want to track the operator or the waste type and so on. So it's not really looked at data, and as such it's quite messy, it's not very clean. Anyway, you can have a look at the size of these things. New South Wales, 280,000 rows. Victoria, 1.6 million. WA, 1.3 million. Now, luckily, Excel now goes to just over 1 million rows. So you can do some serious analysis in Microsoft Excel. You need a big computer, and luckily I've got one. But there was a lot of data work there, and we'll have a look at some of those. Anyway, I'd mentioned some of the challenges: multiple counting, varying methods for classifying wastes and sources and fates, apparent differences in user interpretations of their waste, so that when people have got a waste, sometimes there's more than one category they can throw it into, and which category they throw it into depends on the guidance they get or the culture in their sector or how pushy the regulator is at the time, a whole bunch of things. Storage release spikes, which can happen every now and then, and varying measurement methods, tons, meters cubed, and in some cases, numbers of items. So it was a difficulty establishing a representative baseline. If you've got a slug comes out of storage in a particular year, you don't want to start your projection from that quantity. You've got to find a quantity that's representative. So quite a few challenges there, but some very interesting data. Take a look at this one now. This is asbestos data for Australia across the different jurisdictions, tracking back as far as we could get this information. Not all of this particular set comes from tracking system data, some of it's from landfill data. And look at New South Wales there. In most of the years, according to this, more asbestos than all the other jurisdictions put together. Particular issue with asbestos is that soil contaminated with asbestos or demolition waste contaminated with asbestos is counted as asbestos. So if the jurisdictions have different ways of dealing with that issue, we might get some different numbers. But the one on the right is per capita. We still get massive numbers for New South Wales, and the other ones, South Australia, WA, Victoria, all seem to be pretty similar. Anyway, look, I haven't got time to go into the details too much on that, and I'm not going to do these whole 29. Here's some more selected historical data, and we have to be careful here too of commercial confidentiality. So I picked ones that aren't going to give any games away. Grease trap waste, the other inorganic chemicals, the D groups, oils and contaminated soils, which are not tracked in some jurisdictions. And you can see, look, it's a pretty messy data set, and some things are all over the place. You don't get some nice smooth curves and nice smooth trends. You're getting big lumps and all sorts of stories running, which of course made the job of using this for projections difficult. Here's the fate. Now this is coming out of only 3 jurisdictions, New South Wales, Queensland and Victoria. They're the ones we got fate data from, and contaminated soils, not New South Wales. And those categories are showing landfill as the black, treatment as the blue, and recycling as yellow. There's no red pretty much, a bit of on incineration and a few other things. So that's an interesting story there too of what happens to these materials on a ton by ton basis. Again, I'm only flicking through these. Selected projection, so I picked out a few here. Acids likely to decline mainly because of the expected decline of the aluminium smelting industry. Other inorganic chemicals on the right there, look at that big hat there. That is spent pot lining, which large stockpiles of that from the aluminium industry. So here we have an industry which is essentially appears to be closing down, at least in part, with 900,000 tonnes of hazardous waste sitting in sheds. Now there's a regulator issue there. That high projection there assumes that it bleeds out into the industry, into the waste sector over that time frame. Just an assumption. Non-toxic salts projected to grow strongly because it's associated with coal seam gas, of which there's enormous projections, particularly in Queensland. Here's the projections for the new Stockholm wastes. With some interesting sources here too: firefighting foams and wash waters, biosolids, expandable polystyrene. Lots of these things are finding their way, and the most likely place to have them is biosolids, although there's not been a huge amount of looking for them at present. Some in waste in recycled plastics used in computers. Now, as I said, we're just going to have to scan these things just because of the lack of time. And you can see there's enormous variability. Partly, this again depends on the threshold that Australia may choose if it ratifies these new additions to the Stockholm Convention. Here's some more contaminated soils, asbestos, and look at the contaminated biosolids. Look at that there on the bottom left-hand corner. That huge hat in the high projection is Victoria's stockpile of biosolids, most of which are likely to be contaminated according to the definition we've come up with, which was based on Victorian guidelines, by the way. So potentially a large amount coming into the waste sector there. Clinical and pharmaceutical waste there at the bottom too. Here's the collated best estimate, rising from currently 5.5 million tonnes to about 9.5 over the 20-year projection period, with a big chunk of that, oils, various other types. You get these, I think you get these printouts so you can study these. It's very information dense, and I'm getting the call on already. The high and low estimates, you can see those three combined hats where stockpile releases making an impact on the high estimates there, and there's the low estimate. So you can see now those are together on scale. So they are. You can see we've put into this a lot of uncertainty. There is a lot of uncertainty. A lot of it depends on particular industries that we don't know the fate of. Okay, the infrastructure capacity assessment, we identified 126 companies, 240 sites. We had face-to-face interviews with 23 large operators. We had phone, email, and online survey response with the others, and we got 64% response rate to the surveys. Questions about equipment, recent annual quantities, capacities, plans, and stockpiles. And here's the numbers, except where we thought there's a risk to confidentiality. You can't believe how many confidentiality agreements I had to sign for this project. We were tied in knots, you know. We had gaffer tape all over us. Anyway, so you can see we've got a whole bunch of sites there and their current capacities, and we had to link those types to these waste types, which is also difficult because industry uses a different language from government in talking about these things. Which is one of the issues which we need to use this project to drive change on. Anyway, I'm going to just go over the key findings. New Stockholm persistent organic pollutants. Existing processing capacity is far below our best estimate, assuming ratification of 42 kilotons of demand per year in 2034, and a high estimate of 209. 3 operators, though, are exploring options using existing infrastructure, but definitely there is a shortage of infrastructure should that come on board. Chemical and physical treatment plants, the standard toxic waste plants, if you like, falling demand due to a decline in manufacturing, particularly in Victoria and New South Wales, but infrastructure for mining oil and gas waste is growing in Queensland and WA. Spent pot lining for aluminium smelting, national stockpile, 900,000 tonnes. And we already have orphan stockpiles of mercury waste, so this is not an issue that should be glossed over. These are big companies and probably easier to get hold of their necks then in that case, but at the same time, I think we would be saying there should be a plan in place here. Hazardous waste landfill capacity. We found no impending shortage of hazardous waste landfill capacity, but definitely risks because there's such a small number of sites. So from unforeseen events such as site fire or disasters, general disasters in the community that produce large amounts of waste, and legal challenges. Asbestos disposal, abundant options, but high cost in rural areas leading to illegal dumping. Lithium-ion batteries, kilotons likely to be entering the waste stream by 2034 and a fire risk associated with them. Exhaustion of national capacity is modelled for several wastes by certain dates, although the peer reviewers have taken issue with some of those, so that's not, we're not going to hang our hats quite on those yet. As I said, this is draft report stage. And finally, strong feedback from industry that hazardous waste policy is not always helping. In particular, inconsistent levies are driving interstate transport, and the lack of certainty of whether, when they build something, they'll actually get it, impedes investment. Yeah. Okay, that's it. That's a quick scan of a project that's not quite complete. As you can see, it's very information dense. If it's something up your street, that report will be made public in probably a couple of months' time. Thank you.